Hey everyone, welcome to the channel. My name is Nader. In this video, we're going to go over a bunch of exercises together to get more practice with our introduction to object-oriented programming in JavaScript together. In the previous video, we went over kind of an introduction of the major concepts of object-oriented programming. We saw how we can create a class and how that's very similar to kind of the new function syntax where we can actually create objects and use the this keyword. And we saw constructors and methods. So this set of exercises is really meant to tease our brain and get more practice with the class keyword, as well as to actually think of generally how to model different types of objects. So there's some really nice open-ended questions in here as well as a fun bonus to really tease our brain. Let's just get right to the exercises. Okay, so as with the previous exercises, if you haven't seen this before, what I'll do is I'll go through kind of a bunch of comments on each of these. And I'll just give a bit of preamble and setup, and then I'll give you a chance to pause the video and try the exercise yourself, and then we'll go through a possible solution together. So these exercises are also posted on the GitHub repo, so that's in the description. You can definitely get it from there if you don't want to like type it all out yourself manually. So whichever is easier for you, it's all available on the description. Perfect. So for this warm-up, what we want to do is we want to create a class called animal. And we want to have this animal class allow us to pass in two like properties or fields to the animal constructor, which gets set to the instance, right? So this instance, we want to be able to set a type for the animal when we create it, as well as a name for the animal. And we can expect both of these to be of type string, so we don't have to worry about like checking them and all that kind of stuff. And then what we want to do is we want to create two instances of the animal class, and we can choose whatever name that we want for this. So whatever kinds of animals are your favorite, and you can pass it your own type and name for each of them. Then you can print out both of these animal instances. So these instances of the animal class that you set up. Then what you can do is try to change one of the names of the animals and print it out again, and maybe even print out both to make sure that only the name changed on one of the animals. Okay, so remember that this is going to make ample use of the this keyword within the actual class itself, but outside the class, we're really referring to the instances of the class. So give that a shot, and then we'll go through this together. All right, so here, let's start with creating our actual class of animal. So we saw that previously we can do this keyword, class animal. There's no parentheses here because it's not really like a function, but we have the curly brackets to denote the start and end of the class definition. And we saw in the previous video that there's a special method called the constructor method or constructor function with classes that's kind of expected to be there and actually build up our class. And it's what we can pass in arguments to actually build up and start constructing our instances of these classes. So that looks like this. We're going to have constructor. And this is a method or a function, and we can tell it how many parameters we have for this constructor. So in this case, we have a type and we have a name. So the order doesn't really matter. You just have to remember that whatever order you choose is whatever order you expect the person using your class to actually use as well. So if we switch these around, then when we create a new animal, we would switch these around as well. So I'll mention that when we actually create our animal instance together. So once we have these actual arguments passed in, so when we're actually constructing this, what we want to do is we want to set these to the this value of this instance of the animal class. So in this case, we can say this.type is equal to the type. Now this looks confusing, right? Because what's happening on the right is this is the arguments that's being passed in, right, to the constructor function. And on the left here is the actual field that we're assigning it to in the instance of this class. In this case, they have the same name. They don't have to have the same name. All right. Then I'm going to say this.name is equal to name. And that's our animal class right there. Okay. So that's the definition. So we can say this is our animal class definition. And in this case, it just has a custom constructor. So to actually create two instances of animal, I can say, for example, const monkey is equal to, we have to make sure to use the new keyword when we're creating classes. Let me just zoom in a little bit more here. Just to make it a little bit easier to read as I'm writing this definition. So we want to make sure to use a new keyword, and we want to construct it with the animal constructor here. So you can see I'm being prompted for a type and a name in VS Code. It makes it a little bit easier to see kind of what the definitions of the constructor are in this case. Depends on what editor you're using. Not all editors will show this to you, but this is coming from this constructor right here. So the first string that I pass in this case is going to be the type. The second string is going to be the name. So the type in this case is going to be a monkey, and let's give a name of Abu. Okay, one of my favorite monkeys. And then what I'll do is just to make sure that this works, is I'll console log out monkey just to start, and I'll bring up my terminal here, and I'll make sure I'm in the right folder. Good. And I'll run node, and I'll do warmup, and there we go. Right? That's pretty awesome. So we have a custom class called animal. Type is Abu, or type is monkey, and name is Abu. All right. Now let's make another one. I'll say const maybe fish, and this is going to be a new animal, and this is going to be a type of fish, and the name, let's go with Nemo. Okay. So I can do console.log here of our fish, and what we'll see is the same thing, but now with our fish. So these are two different instances of the animal class, and they are totally independent of each other. They share the prototype of animal, but their actual instance fields, which are their type and name, are totally independent in memory. Okay, so now what we want to do is we want to change the name of one of these. So for example, if I want to change monkey's name, let's just say monkey.name is equal to, I forget the name of the Planet of the Apes one. Is it Oscar? Let's go with Oscar. I think that's the one. Maybe I'm wrong. But then I'll console.log out monkey again. And let's try this one more time. And what we'll see is that first we have Abu and Nemo, which is what we had printed above. And then we changed monkey's name to be Oscar. Right? So going forward, this object, so the variable monkey is now pointing to this object, basically. Okay, so we've permanently lost the string Abu. Okay, perfect. Hopefully that makes sense. Let's check out exercise 1. Okie dokes, so we're stepping it up a bit here. So for this one, what I'd like you to do is create a class called student. And this student's constructor is actually going to have 3 different parameters. It's going to have a name, and I forgot to rename this to student here. My apologies. It's going to have a name. It's going to have a major, both of which are strings, and it's going to have grades. But grades is going to be different. It's going to be an array of numbers. Okay, so we have to make sure to pass in an array of numbers. For now, we'll assume that that's the case, but in future videos, we'll see that we probably want to check the type of the thing coming in to make sure it really is an array, just so that we don't have errors in our class code. So once we have that, that's all in the constructor. We assign it to the this value, just like we did previously. What you then want to do is create a method on the student class called addGrade, and it's going to have one parameter called grade, and it's going to take that grade and it's going to push it onto the grades array, which was created in the constructor. Okay, so the state for our student consists of 3 things: a name, a major, and grades. And grades is an array or a list of numbers. Okay, so we can manipulate that list by adding more grades onto it using this addGrade method, which is available to all students. Then what we want to do is we also want to add another method onto student, and this is going to be called GPA. Okay, and what this is going to do is it's going to return the average grade from this grades array of that instance of a student. Okay, so we can have different students, just like in real life, and each student will have their own set of grades, and we can calculate the GPA, or the average, for each student independently, and each student will have their own GPA. So you can test it like this. We can create an instance of a student just like this. We can say like const Eva is a new student, arts, Eva arts, and then these are Eva's grades. And then we can print out Eva in this case. And we want to use the GPA method on Eva to print out their average grade. In this case, with this particular set of numbers, if you use this, we would get 84.33 repeating. Okay. Now, ideally what you can do is, just to get more practice, you can add a second student if you want, or a third student, and make sure all the different methods work. But you can also probably test the addGrade function if you want. I didn't do it in this case, but I'll do it in the actual demo that we'll do shortly. I just wanted you to get more practice writing methods for this, and also see if you can actually write out some logic inside one of the methods. Perfect. So give that a shot, and then we'll go through this together. All right, so to start, let's create our class student. Okay, and our student's going to have a name, a major, and grades. Okay, so in here, I'm going to create a constructor. We're going to have a name, we're going to have a major, and we're going to have grades. Grades. So we want to assign these to the instance of this student, right? So in this case, I want to say this dot name is equal to the name that we pass in. This dot major is equal to the major that we pass in. And then this dot grades is equal to the grades that we pass in. Now again, just to be super clear, these are the arguments being passed in, which are what you see in orange on my screen. Everything that's a this dot something is the actual field or the instance property inside the actual class itself. In this case, they share the name, but we could make this different. For example, I could say this dot n, for example, right? And then the instance's name would actually be accessible by n instead of name. Okay, but that's a bit confusing, so I will leave it as name. Perfect. So then what we want to do is we want to create a method on student called addGrade that has one parameter called grade, and it pushes the grade onto the grades array. So I'm going to do addGrade. And I forgot to add my parameter here, so it's going to be a single grade that we can add one at a time. And what do we want to do in this function? Well, we want to take the grades for this instance and add the grade that we get to it. So we're going to say this dot grades, which is our instance field right here, dot push, and we can add to it like this, and we can push in the grade that we get passed into our function. I'll show you a demo of this since I didn't put it in the instructions. I just wanted you to get more practice. And if you did try this out, fantastic. Now, the interesting one here, we want to create a GPA method, right? And intuitively, this would return the average grade of all the students' grades. So if this is an array of grades, we want to return the average number in there. So we're going to say GPA, and this has no parameters, right? Because it's just going to return kind of the average grade. So you could have done this many different ways. So I'll just go with the simplest way to start. And I'll like kind of just in logic how you would calculate an average, but you can probably use different array methods to actually calculate this, but I'll keep it super simple. So I'll say let average grade. I'm going to start at 0. And then I'm going to say for const grade of this dot grade. So I'm going to loop through all of the grades inside of our this dot grades, which is this particular instance's grades. And I'm going to say average grade, we're going to add it to the average grade, plus equals the grade. Okay, so we're going to keep adding them. Then what we want to do is we want to divide by the number of grades, right? So for example, if I have 3 grades, so I add 95, I add 75, I add 83, I want to then divide it by 3 to get the average. Okay, so then what I want to do is I want to return the average grade divided by this.grades.length. Always misspell length. There we go. All right, definitely a little bit tricky here. You could have done this in a separate step, but I returned it and calculated it in the same line. Now you could definitely shorten this, as I mentioned, and do it kind of all in one line with array methods and things like that, but we'll leave it at this for now. Perfect. So then what I want to do is I want to try to create Eva here, just so we can see what that looks like. So I'm going to say const Eva is a new student, and I'm just going to console.log out Eva. Okay, so let's see if this actually works. So I'm going to pull up my console here. I'm going to run node, and this is exercise 1. And there we go, right? So we have Eva. Eva's major is arts, and Eva has these 3 grades. Okay, so then what I can do is I can say console.log, and I'm going to say eva.gpa, and I can call this function. So I'm calling this function on the instance of student called Eva, who has these grades. So this dot grades is going to be these grades. Okay, and I'm going to call this GPA function right here, which is going to do this code. And if this dot grades is going to be this array right here, then we're pretty good, right? So it's going to calculate the average of those grades. So let's run this again, and there we go, right? We get 84.33 repeating, which makes sense. So what we can then do is, just so you can see how this add grades works, is we can say eva.addGrade. Let's say Eva takes another course or something, right? And we want to add, I don't know, like let's say Eva gets 89. Okay. Now what we can do is I can run this code again. And now this has been added to the instance of the student, Eva. And Eva's grade is going to be different, right? So if I run this now, what we'll see is we went from an 84.3 GPA to an 85.5 GPA, slightly higher. Okay, so hopefully that makes sense, right? If I made a second student, they would have their own name, major, and then a list of grades, and we could manipulate each of the names, majors, and lists of grades separately, depending on the student, which is really, really awesome, and the whole point of classes and object-oriented programming. So when I talked about managing the state, what I really meant was managing this information for each instance of the student in this case. And when I talked about code for each of the instances, we're technically talking about this logic right here, the methods that actually operate on that state for each of the instances. Okay, let's take a look at exercise 2. Phew, fun stuff. So I have a whole bunch of tricky ones planned for you, so let's keep going with this. So for this one, what I'd like you to do is create a class called Bookstore, okay? And the Bookstore's constructor is going to have a single parameter called books, right? And we can assume that this is going to be an array of book objects. Now, this is where things get kind of trippy. So you're probably thinking, like, what on earth is a book object? I know what a regular object is, right? But what is a book object? Okay, so hold on to that thought and I will mention it shortly. Then what we want to do is we want to assign the argument passed into the instance within the constructor. So same thing as before, like this.books is equal to books, for example. And then our bookstore class, we want to add a list books method onto it. Okay, and the purpose of this method on the bookstore is to loop through and print out all the books in the store. And what we can do is we can assume that all of the book objects in the store, as we're looping through them, is going to have a name property and an author property. Okay, so for example, you can assume that the structure of the books, in this case that we're looping over inside the bookstore, are going to have a name and an author. I spelled author wrong here. Let me fix that for you. There we go. So we can print out a string like this, assuming that we call each thing that we're looping over book in this case, right? So I'll show you an example of what that will look like down below, so it makes more sense. So then what I want you to do is I want to create a second class, okay? And this class is going to be called book. And the book constructor is going to have two parameters itself. It's going to have a name and an author. Hopefully you can see where this is going. Right? We want to then assign these to the instance within the constructor, right? So this.name and this.author, all that kind of stuff. And we want to create two books once we've done that, right? So notice that the book doesn't have any extra methods, okay? I want to keep this example not too complicated because we could definitely add methods onto the book and we could actually use those, and we can see how that will work in future videos as well. But for now, what we want to do is we want to create two books. So here's an example, right? 1984, a great book. And we would pass in that name, right? 1984, and the author, George Orwell, right? So if I created const HP is a new book, Harry Potter, J.K. Rowling, right? Now, this is where we get back to what I mentioned earlier. When we created the bookstore, we mentioned that we're going to pass it an array of book objects. So now what we have is these are two book objects, right? We just created two book instances like this. So these are book objects, right? Each has a name, each has an author. So when we create our new bookstore like this, we can pass it an array of objects, which are books. All right. Then what we want to do is we want to make sure that this works. We want to be able to call bookstore, which is our instance of the bookstore, .listBooks, which is our method on the bookstore, and it should actually print out this, which is the name and author for each of the books inside of the bookstore. Okay, so definitely a lot more going on. You have a lot more things to kind of tie together, but give that a shot and then we'll go through it together. Okay, so let's start with the bookstore class. So we're going to say class bookstore, and it's going to look like this, and it's going to have a constructor. And we mentioned that it's going to take some books. Okay, and we're going to pass it an array like this, and we're going to assign that to this.books in this case. So I'm going to say this.books is equal to books. Okay, so that part hopefully makes sense. Then what we want to do is we want to create this function right here, step 3, a list books method on our bookstore that's going to loop through this.books and print out all the books, assuming each has a name and an author property. So let's do that right now. So this is going to be called list books and some method. So it's going to look like this. It doesn't have any parameters, right? Because we just want to list out all the books in this.books. So we're going to say for const book of this.books. So we're going to loop through each of the books. You can do this without a for loop. You can do this in a few other ways too. I'm just going to go with this. And I want a console.log out. And I'll just copy this here just so it's a bit easier so you can see what that looks like, right? I want to log out the book's name and then by, and then the book's author, just like this, right? So in the case of 1984, if this is the name, it would say 1984 by, and then George Orwell is the author, just like this right here on line 30. Okay, perfect. So now what we want to do is we want to create some books. Now notice that technically we could just create objects that have these two properties on them, but I want you to get practice with actually thinking of things in the context of custom objects, hence the whole point of doing object-oriented programming. Okay, so next we're going to create our class of book. Our instances of books are going to be created out of this template, and this is going to have a constructor, and each of our books is going to be having a name and an author, which we're going to say are both strings. Okay, so we're going to say name and then author. So then I'm going to say this.name is equal to name and this.author is equal to author. Perfect. And I'm not going to add any methods on here, but we could if you wanted to. For example, if we did add a method onto here, we could actually call that method over here. We're going to do a lot more of this when we get into the next video, which is polymorphism and inheritance. So definitely stay tuned for those because we're going to really kind of tune it up over there. But if you want more practice, definitely add a method here for fun. You could even call that method in this loop if you want. I'll just pause here real quick to mention that ideally what we would do is we would actually have a way to display the book, right? So in theory, what we could have is probably like a display book function over here, right? And we could probably put this console log in here, then we could just call that book's method. In fact, what I'll probably do is just to clean this up at the end, just to show you how you can refactor this a little bit. I'll actually do that to show you what I mean. But let's keep it simple for now. So then what I want to do is I want to create all these objects. So I'm going to create my books first. Okay, just like that. So 1984 are these two books. Then I'm going to create my bookstore. I'm going to pass in the books. Now notice that I had to do this in the correct order, right? So in order to create my bookstore, I had to pass in the books. So I couldn't have created the bookstore before I created the books, right? Unless I can add the books later or something using like bookstore.add. Okay, so if I wanted to pass it into the constructor like this, I would have had to pre-make these books. Okay, pre-write, I guess in this case, although I didn't write these books. They're great books. So let's next, so we have our bookstore, and then we want to call bookstore.listBooks to see if it actually works. So we're going to do bookstore.listBooks, just like that, which is going to call this function right here. All right, I'm going to pull up my terminal again. Let's run node exercise 2. And there we go. Isn't that awesome? Right? So we're looping through these books and we're logging line 41 in this case, which is our template string, which makes it look like that. Perfect. Now I'm just going to close the terminal for a second. I'm going to show you that refactor that I mentioned just in case you're curious. So what we could do is we could say display books in here, or display book, I should say. Right? And I can actually take this console log and I can do this. Okay. But instead of book.name and book.author, I want you to think, what is this going to be changed to? Okay, so what we want to change this to is this.name and this.author because we want the particular instance of that book. Now, if we do this, what we can do is instead of kind of having to do all this logic in the list books, I'm going to comment this line out and I can actually just say book.displayBook. All right. And it's going to come into the book and call its display book function. Now, if I rerun this, what we'll see is the exact same result. Now, arguably, this is much cleaner because what we want to start doing eventually as we get better with object-oriented programming is moving the logic that is customized for that object and really related to that object inside its own class. The bookstore doesn't really need to know how to display the book. It's really the book's job to tell the bookstore how to display itself, right? Like for example, it has a cover and it has like the list of author, table of contents, whatever it is, it should know about itself enough to be able to tell the bookstore, hey, this is how you can display me. Okay, you can make arguments for the other way around for sure, but hopefully you can see that this probably makes a little bit more sense than trying to manually do it inside the bookstore class. All right, now that is a good segue to our third exercise. Let's take a look. Now, before I kind of read into this one, I want to just give you a bit of a caveat. This one is meant to be very open-ended, as I've mentioned here at the bottom. I want to give you the creative freedom to actually think about how to model this class. When you kind of are working as a software engineer or web developer or even building your own projects, a lot of the time what you want to do is build your own custom classes for things that don't exist. And a part of that process is trying to think about modeling the state or the data of those objects, as well as the methods or logic that actually works on that state or works on the interactions between different objects. All right, so this is really meant to be that kind of modeling style of open-ended question. In fact, I would encourage you, if you have it, to whip out your notebook or pen and paper, or you can even just do this inside your editor or write it down in a text file or something. But if you can draw this out, it really becomes a lot more fun and enjoyable. And I highly encourage you to do that because that's normally what I end up doing when I do these models. Okay, so with that out of the way, let's take a look at this one. I would like you to look up the retro arcade game, Space Invaders. All right. If you've never played this game before, you should probably just stop watching this video and go play it and try it out. It's a fantastic game, super old school. In fact, when I show you pictures of this or you Google it and you're not really sure what I'm talking about, I'm sure you've probably heard of it or seen it somewhere. It's one of the most famous games ever created. So this game, and I'll show you pictures of this, has a player, which is a spaceship, and then enemies, which are these little flying aliens above in the screen. And the goal as a player is to kind of avoid the bullets that the aliens, I guess they wouldn't be bullets if they're aliens, whatever it is that aliens shoots, goo or whatever it happens to be, psychic waves. And your player spaceship is trying to avoid these, and you have some obstacles to help you out. And you're trying to shoot your own lasers or bullets to actually fight these aliens and kind of eliminate them before they actually take you over. All right. So it's a relatively simple game. In fact, so simple that it's one of the first ones that ever came out, apart from like Pong and Pac-Man and things like that. But what I really want you to do is try to ask yourself the question, if you were the one building this game, right? And even if you were just to focus on the alien or the little enemy and the spaceship or the player, how would you model those classes? Okay, I want you to try to think, what are all the different fields, right? So what are all the different properties inside of each of these classes? And what are the methods or what are the different bits of logic that you might add into each of them? And how would they interact with their own fields or state and maybe other fields or state from each other? Okay, try to imagine this. If you're playing the game, right, what would actually happen? Like what code do you think might run within each of these classes, right? You can get creative with this, right? If you don't like the regular game, you can spice it up and add your own stuff in there. This is meant to be creative and fun, right? The whole point of this is to get practice thinking about different objects, but objects that might interact with each other. All right. As I mentioned, definitely try it out on paper and pen, pencil if you have that, or crayons, whatever makes you happy, or text if you don't have that easily available, or a drawing program if you do have that. Then what I want you to do is I want to take your diagram that you created or set of instructions, and I want you to actually try to implement them as classes as simply as you can. Now, you can obviously create very elaborate and complex systems, but I'd like you to try to feel what it's really like to take something that you drew and you envisioned from like a game concept and actually implement it in code. It's a really wonderful feeling and something that really you get only better at if you start practicing. Okay, so I'll give you a chance to try that out and then we'll kind of go through this process together. I can't wait. All right, so to start, I'm just going to Google for this just so that we can kind of see what this whole Space Invaders thing is about. So I'm going to pull up my browser over here. I got Google open. I'm going to search for Space Invaders. Okay, and I'll maybe zoom in a little bit more. So you can kind of see already, right? Like hopefully these pictures maybe ring a bell or you've seen this before. Right? I'll just go to Google Images here. Right, so this is basically the game. You can see there's different versions, right? If I remember correctly, I think this is like the original one, right? So you're basically on the bottom here. You have these little obstacles, right? And you're this player, so you're the green one on the bottom, and you can slide along, right? So you can have a certain number of lives, it looks like. So in this case, 3 lives. And then these little aliens are shooting at you. Now, in this case, notice that there's a few different types of aliens, right? So for example, this one, maybe there's only one type of alien, right? But this one, there's a few different types, and maybe each of them does something a little bit different, right? We will get to this concept later. This is something called inheritance, which makes this a lot easier, and it's something I teased at in the original introduction video previous to this, right? Now, the main point of this is really just to model out these systems, because that's going to give us the best practice. So let's think about this. Just even looking at an image like this, we have our player. Let's call it the spaceship. Okay. And our player can shoot, but you know, if you've played this game before, maybe you can't just like hold down the button and just shoot infinitely, right? Maybe there's a little bit of a delay between where you can like press the space bar to shoot, for example, right? Because if you could just hold it down and you just kind of rapid fire like a machine gun or something, that would be pretty unfair, and it would have made the game very fun, right? Because then you can kind of wipe out all the aliens very quickly. So the whole point of this, generally speaking, is to be a bit strategic about how you shoot and where you shoot based on the movement of these aliens. So maybe there's some kind of delay. Also, maybe, you know, does the player have any health, right? Is it that if it's like a one-shot like KO kind of thing? Or is it that maybe, you know, you have to take a couple of goo psychic hits from the alien to survive, right? We can design this however we want, right? So we need to track if there's health, maybe. We should probably definitely track how many lives the player has. Now, this is where things get really tricky, right? And this is the entire point of this exercise. Now, is it the player who tracks how many lives there are, or is there some other object, maybe like a bigger game manager object that's tracking the player's lives, right? Maybe there's some parent object that even knows the score. Maybe the player doesn't know the score. Right? Now, we can design this in an infinite amount of ways, and this is actually the field of game design specifically in this case, but it also applies to designing pretty much any kind of system with object-oriented programming. Okay, so let's say that there's a delay. Let's just say that each player has lives, maybe no health, just to keep it super simple. And then what else does the player need to know about itself? Well, here's a tricky one. Technically, the player should probably know where they are on the screen, right? So if you can imagine this as like a grid of X and Y coordinates, if you've studied math before, we technically can position objects on a screen using its X and Y coordinates. So we would probably want to know where the player is on the screen. Now, in the real game, the player is not actually allowed to move up and down. They're only allowed to move left and right. So maybe we only need to track the X coordinate, which is left and right. Maybe we don't need to track the Y coordinate, right? Or maybe we allow a little bit of Y movement, right? It really is up to us. All right. So maybe there's a few other things there. So that's kind of teasing our brain a little bit. Let's go to the enemy. Okay. So what would these aliens each have, right? Could it be that they have some health? Right? Where maybe it takes more than one laser beam to actually make them disappear, right? Or maybe they can shoot, maybe some can't shoot, right? Maybe some can shoot really fast, maybe some shoot really slow, right? What is usually common with this particular game is that they all actually move at the same speed, but maybe they don't in some versions of this game. Right? That would look a little bit strange because some might overlap since it's two-dimensional, but in the real game, they actually move at the same speed, so maybe we don't need to track that, right? However, in the real game, their speed actually increases the longer that you're playing and haven't shot them all down yet. So maybe we do store the speed somewhere. I don't know, right? Maybe the game manager stores it. Does each actual alien needs to know its speed? Probably, I think so. All kind of interesting questions. Also, what might be interesting is each enemy, you can see we have a score, right? So who would keep track of the score, right? Because when we destroy the enemy, well, maybe there's different types of enemies eventually. So each enemy probably has its own score because maybe some are much harder to destroy than others. So maybe we should put the score inside the enemy object, right? Arguably, we could put it elsewhere, but let's go with that for now. So hopefully you can see, right? The entire point of all this is to really pick this thing apart. And the amount of ways that we can put these things together is literally infinite. And that's part of the fun, right? So let's just get back to Visual Studio Code and start actually modeling some basic versions of this out just for fun to actually see how this might play out. Okay. I should probably mention that at the start, what I just did is really start modeling out the field. So the actual properties, so things like the position, the delay, how many lives they have. These are all fields. What I didn't mention really was the methods or the actual logic that would be implemented in each of the players. So one example of a method is the shoot method, right? Or whatever we want to call it, right? So the player knows how to shoot at the enemies in this case. And maybe the enemy also knows how to shoot. So that would be a function that each of those classes or instances of the classes could access to actually do something, right? That's pretty interesting. So let's kind of start this out and see what we get. I'm not going to go too far with this. I just really want you to start asking these questions and actually getting practice writing it down and then translating it a little bit into code. So let's just say I have our class. Now I'll just go with player actually. Let's go with that. Why not? So let's think about the constructor. Okay, so when we create our player, what do we want to pass the player? Or do we want to even pass it anything, right? Or are all of the things already kind of pre-set up? So I want to show you something interesting. Maybe to start, what I'll do is I'm going to use kind of the field initialization syntax, which is slightly different than what we do in the constructor, but it actually functionally does the same thing. I'm going to say the player has lives, and it's going to be 3 lives to start. All right, maybe they also have a delay, or I'll call this like a shooting delay, right? And maybe this is like, I don't know, maybe like 2 seconds. Okay, maybe we do this in milliseconds to make it super precise so that we can kind of have different levels of responsiveness in our game. Okay, so maybe I'll say this is in milliseconds. All right. Maybe they have a starting X position and a starting Y position, right? And then maybe I can say like Y position, I don't know, like maybe from the bottom of the screen. So normally when you use games, it's like 0, 0 is like the top left. So just for fun, I don't know, I'll just maybe say it's like 500. I'll just go with 500. Okay. And then the X position, well, I would probably want this to be in the middle of the screen to start, right? Arguably, you could start on the left or on the right, but let's just say it's also in the middle. Maybe our screen is 1,000 across, so maybe also in the middle. Okay, I'm just making these numbers up just so that we can think about these issues. Okay, perfect. Now, we could probably put HP in here if we had HP. We could put many other things in here, but let's just kind of go with that. Now, what I just did here is set up the default values for when this class gets constructed. So technically speaking, I don't really need the constructor here because I'm not actually using it. JavaScript is going to input this constructor for us automatically because it actually uses this behind the scene to set these up using this value, this.lives equals 3, this.shooting delay equals 2000, etc., etc. But if we're not actually using it in this case, we can just leave it out. Okay, so let's try this out. So I'm going to say const spaceship is equal to a new player, and notice spaceship. Oh my gosh, my brain. So in this case, if we log this out, I want you to think, what are we actually going to see inside a spaceship? All right, let's take a look. So I'm going to pull up my terminal here. I'm going to clear that out. I'm going to do node exercise 3. And of course, I didn't log out my spaceship as usual, so I'm going to log that out, We're probably like, we're gonna see nothing at her because you always forget to log stuff out. So there we go, right? We get our player. We named a player in this case. We could probably name it spaceship, whatever makes you happy. And in this case, we have a lives of 3, shooting delay of 3000, Y position 500, and X position 500, right? Because that's what we set up for the default values for our player when it gets instantiated. Perfect. So that's pretty cool. Let's take a look at our enemy. So I'm gonna say class enemy, or enemy. Sure, we can maybe call it alien, but let's just go with enemy. I'll just make it super generic. Now, what do we mention that our enemy has? So maybe they have an HP. Maybe to start, they have 1 HP. So as soon as they get hit, for example, if this goes to 0, we decrement it by 1, and then they disappear from the screen. So the most basic enemy has 1 HP, for example. Okay. Maybe they also have a shooting delay. So I'm just going to copy this one here. So maybe by default, they can shoot, like let's just say even less often, because there's just so many on the screen. In fact, maybe we should probably increase this even higher, like 9,000 or something. Okay. Now, maybe what we want to do is make it so their shoot method actually randomizes a number, right? So that is entirely possible as well if we were to add that logic. Maybe they also have an X and a Y position. So I'm actually going to start that. Now, this actually probably doesn't make sense this way by default, because if we were to create, like, let's say if you look at this image, if we have, I don't know, like a couple of dozen of these aliens to start, if they all started at this position, that wouldn't really make sense, right? Because they would all be on top of each other. And it would look like there's just one of them there, but there's actually, I don't know, like 30 of them there or something, right? And then we would see all these bullets showering down from them. So what we'd probably want to do is actually choose its position and place it in there randomly, or actually with some kind of order, so it's like in a grid. So this probably actually doesn't make sense right away. In fact, it kind of does make sense, but we don't want to instantiate it to 500. We probably want to have it as nothing to start, and then we will actually do this inside the constructor. All right. So in this case, it probably does make sense to put a constructor because we actually want to put it in the correct spot. All right. So what else did we mention? We have each one has its own score, right? So maybe the basic score for one of these aliens at the basic level that has 1 HP, maybe that's 10. All right. So the constructor for this, maybe it would look something like this, right? So in this case, we do want to be able to set the Y position and X position. I should probably switch that around. Usually people like to do X and Y, so I can do X position, Y position. And then we'd probably do this dot X position is equal to the X position, and then this dot Y position is equal to the Y position, right? So the way that we could probably do this is we could create a loop that actually starts placing these on the screen at different increments for both the X and the Y. Now, I'd like to leave that to you as an exercise if you're interested, but it's a super cool thing to think about. Now, I don't want to spend too much time on this, but what I'll do is I'll create one enemy just to see what this looks like. So I'm going to say const alien. I'll say alien 1. So I'm going to create many of these later. Equals to new enemy. And let's just give it a position of, I don't know, like 10, 10. Okay. And I want to console.log out my alien 1. Let's take a look at what we get. There we go. So that's pretty cool, right? We have our enemy, 1 HP, shooting delay, all that kind of stuff. And its X position and Y position are set to 10 and a score of 10 as well. Now, if we forget to put these in, look what happens, right? You can probably imagine that they get set to undefined. All right, perfect. Now, what would be really interesting is to actually add methods to this. Now, in the interest of time and also to just give you more freedom to test things out yourself, I'll just give you a really basic example of what might be something that we could do. So for example, we could create inside our player a shoot method. Okay, and then this would like shoot a laser upwards. And maybe this laser has some kind of damage, right? So maybe the player has like a damage property or something, right? Or maybe there's upgrades for the laser. The possibilities are literally endless, right? That's why we have so many different types of games in this world. A lot of fun to think about. Now, same thing for enemy, right? Enemy would also have a shoot, but the shoot for enemy would be quite different, right? So this one would be shoot a something, whatever enemy shoot, downwards, right? Maybe the speed is different depending on the type of enemy. Maybe the delay is different. Maybe the damage is different. Maybe the visuals are different, right? So we can use this state to figure out kind of how this might look, and then we can actually action it. Now, if you're thinking about like how to actually get this to show up and on the screen and render all the different pixels and everything, that is a whole nother story. And usually that's what people use game engines for. But behind the scenes is this code that usually is running to actually make those pixels move on the screen and actually give them their logic and behavior. And that is what we're interested in when it comes to object-oriented programming. Okay, I hope you enjoyed this one. It definitely was a lot of fun to think about and walk through together. I would love to hear your ideas in the comments if you came up with some cool examples. All right, now to kind of wrap this one up, I want to show you a bonus. All right, so this is a fun one. I made this one a little bit challenging, just like the previous one, however, less open-ended, but still open-ended enough for you to actually try to figure out how to code this, probably fail multiple times and struggle, and then actually hopefully learn something as you eventually maybe get the answer. So what I'm gonna do in this one is kind of walk through a little bit more detail what I'd like you to do, and then I'll set you off to do it, since it's definitely a bit of a doozy. So in this bonus, I'd like you to see how you can create what's called a factory class or a factory function. This is a design pattern, which is just a way about thinking about classes and object-oriented programming and other methods of coding to actually do a certain task in a very specific and structured way. In this case, a factory is very common in object-oriented programming languages like Java and C++, where we're going to actually use a class to create other classes. Okay, now that sounds totally wild, hence why it's the bonus. So let's go through this together. I'd like you to create a class called enemy factory. All right, as the name kind of implies, this is going to be a factory that's going to be able to churn out different types of enemies for us. I would like you to make the following code work. I'm just going to leave it at that so you can play around and try to make sure you understand what's happening by testing out a bunch of different ideas. So let's take a look at this code here. I'm creating an instance of a new enemy factory, right? Then I'm creating an instance of something. In this case, I'm calling our factory and I'm calling the generate flying enemy method on it and passing it a string Batman. Okay. And on that thing I get back, which looks like some kind of class or object, I am going to call the fly method. Batman can fly. Now, I want to mention that as you're doing this, I don't want you to just simply return an object. I want you to actually return a class from this generate flying enemy function. All right. So this is returning a class called flying enemy, which we are then going to instantiate and return back so that we can actually fly with it. Then what I want you to do is slightly different. This is a method on the enemy factory itself. So we had to create an enemy factory using new first. Another possibility is that we can use the enemy factory object itself, which is the class itself, and we can call .generate swimming enemy on it like this. So this is just a different method to show you how another way of using factory functions might work. In this case, we're going to pass it Aquaman as a string, and then we can actually call swim on this class object or instance of a class object that comes back. So the way to think about this is that enemy factory is going to have a method that's going to be called generate flying enemy that takes a string. It's going to return back a instantiated class of flying enemy already created with Batman in it. That's why we can do flying.fly in this case. I probably should have called this Batman.fly, but that's just what I went with. This is slightly different. This is a what's called a static method directly on the enemy factory. So this is actually not on the prototype, but I'd like you to think of how you can assign something directly to an object. In this case, the object just happens to be a class. This is meant to be challenging on purpose. But the same thing is going to happen here. It's just going to be an instantiated version of a swimming enemy class with the string set to the this.name, for example. And in this case, it's going to have a swim method on that class instead of a flying method. Okay. Then once you have that working, I'd like you to think of what are the differences between these two. Which one of these do you actually prefer? And when might you ever even use this? Is it even useful, right? Once you've thought about those, I'd like you to actually log out all the property keys for each of these objects right here, right? So using object.getOwnProperty names. So a lot going on with this bonus. Definitely is a challenging one, meant to really kind of push your limits of understanding. Try it out and let's go through a possible solution together in a sec. All right. So to start, I'm going to create my enemy factory class. So I'm going to say enemy factory, just like that. And step one, then I want to make this work. So I'm just going to copy this code down here just to see if I can get it working. So I want to be able to say new enemy factory, generate that. And then on the instance of factory, I want to be able to call generate flying enemy. I'm actually going to comment these out for now because I'm going to test the first one first. So what this means is that we have a method on our instance of factory, which means that we need to create a generate flying enemy method inside our enemy factory class. Also notice that we're not actually passing anything into the constructor here. So we don't really need to make a constructor for this if we're not passing anything in. So let's try this, generate flying enemy. This is going to take, looks like a name, so I'm just going to go with that. And now what we want to do is we want to return a flying enemy class. Now I mentioned you can technically do this with an object, but I want you to practice this with classes because the whole idea of factory functions in the object-oriented programming sense is to return classes from these things. Now, how can we do that? Well, there's a couple ways to do this. I'm going to do it one way. This is probably actually not the best way to do this. I just want to show you that this is possible. Okay, I'm actually going to create the class inside here. Okay, so I'm going to say class flying enemy, and I'm just going to kind of define it in here. Now this flying enemy, it's going to have a constructor that's going to take a name. Okay, so I'm going to just call this constructor, and I'm going to say it takes a name in this case. And I'll just call this slightly different just so it gets less confusing. I'll call this flying enemy name just so that we don't get confused with this name and this name. I'm going to say this.name is equal to flying enemy name, just so it's a bit clear as to what's happening. So this.name is going to be the instance of flying enemy. Flying enemy name is what we're going to pass in the argument for when we create a new flying enemy. And then name is the argument to the generate flying enemy function inside of enemy factory, which in this case is going to be Batman. Confusing, right? All right. Then we see that on our flying, which in this case is Batman, I guess, this is what's returned from this method on the enemy factory. So we actually want to return a new flying enemy from this so that we can call the fly method on it. But the fly method needs to be on the class. So in this case, we don't have that. We only have a constructor. So I'm actually going to add a fly method here on the flying enemy class. And inside of there, I want it to be able to say Batman can fly. So in this case, what is Batman? Well, it's going to be this.name. So I'm going to say console.log. I'm going to put a template string in here, and I'm going to say something something can fly. And this is going to be this.name, right? Which in this case is going to be passed in as a argument to the constructor. So what do I want to do? Well, I want to instantiate a new flying enemy and return that. So I'm going to say return a new flying enemy, and I'm going to pass it the name. All right. And that's going to create this object or instance of this class, hook up all of the instance fields, hook up the methods, and then return that back to us so that we could actually use it. Let's check this out and see if it actually works, because this looks totally crazy. So I'm going to run a node bonus exercise. Look at that, right? Isn't that amazing? That's pretty cool, right? Now, I want to show you something even crazier for a second. Now, in theory, what you could probably say is, Nader, why are you putting this in here? This is kind of weird, right? Why don't you just put it out here? You definitely could. I just wanted to show you that you could put it in here so that everything is encapsulated inside the enemy factory. Now this syntax is going to look a little crazy. I'm just going to refactor this slightly to show you something that's possible with classes that a lot of people don't realize right away, which is that we can use them on the right-hand side of an expression. So in this case, I can do a return, and I'm going to create a new version of this class. So I'm going to wrap it in brackets, and I'm going to pass it my name. Just like that. I'm going to comment out this return. So what I just did here is literally the same thing as this code. But what you see is that this is technically now an expression, right? We can actually use classes and an expression, which is pretty amazing, right? We don't actually have to only have it as a definition, which is what we had earlier. This is a slight semantic difference, but it's also very powerful, and a lot of libraries use this behind the scenes to do very, very cool things. Now this syntax arguably is way worse to understand than this one, and I totally agree with you. In fact, you're probably going to have to look at this for a little while before it makes any sense, but just to prove to you that it does work the same way, look at that. Okay, all I really did was basically this, but I turned it into one line of code. Or one expression, I should say. Okay, I'll leave it like that for now, just so you can compare the two and see which one you like more. In fact, if you can understand this expression, there's a lot going on in here, so that would be very awesome for you to try to parse that. Now, we got this one working, but what about this one? So if I run this code, let's see what happens. Well, we get an error. Enemy factory.generate swimming enemy is not a function. Okay, well, let's try to parse this and think of why that might be. Well, we're not creating a new enemy factory, which means we're not creating an instance of this which has the method hooked up to it. We're trying to grab this directly off the enemy factory object. So let's take a look at this. Let's log out console.log object.get own property names of enemy factory. Let's take a look at what's actually in there. Is there a generate swimming enemy? You can probably guess no, but for now, let's take a look. Length, prototype, and name. Okay, so nothing is really in there. Now, I don't want you to get too confused by the name, because this is actually a different thing than this name. Name is a bit of a confusing name to use in JavaScript, because a lot of things have names. Specifically, the constructor has a name property on it. And the prototype as well. But in this case, name is not this name, just to be super clear. But most important thing about looking at this is that there's no generate swimming enemy. There's also no generate flying enemy, right? And that's because we never attach anything to this object. So we can grab enemy factory.name, right? So for example, if I comment that out, I can say console.log. I can say enemy factory.name, for example. Like I can grab that property off of it, right? And you can see we get enemy factory, right? I can do enemy factory.prototype and .length, right? Which is the argument list for the constructor. But in this case, we don't have generate swimming enemy. So we need to assign that to this enemy factory. So what I'm going to do is I'm going to assign it directly to that object. So check this out. I'm going to say enemy factory dot generate swimming enemy, right? And now what this is going to be is it's going to be that function. Okay, so how can we actually make this work? Let's take a look. So I'm going to call, this is going to be equal to a function. And this function, I'm just going to close this console for a second. It looks like it takes a name. Okay, so right in here, I can say that this takes a name. And if you think about this, this is actually the same thing as this method right here. So we are literally creating this, but on the object directly. It just has a different name in this case, so we can differentiate them. So I am going to actually just do this the first way. I'm going to say class swimming enemy. Okay. And inside of here, what I want to do is I want to say, let's just say for now, just so you can see a slightly different way of doing this, I'll just say the name is equal to name. Now, I'm purposely showing this syntax just to also confuse you a little bit. This is this dot name. This is the name that's coming in from our argument, or the parameter in this case is called name. We're assigning that parameter, or when it turns into an argument, to this.name. This is a short form for this right here. So if I named both of these name, we would have the same thing. All right. Awesome. Cool. So then what we want to do is inside of swimming enemy, we want to be able to add this swim method. And inside of here, I'm going to basically copy this log right here. I'm going to say this.name, but instead of can fly, this is going to be can swim, right? Because this is a swimming enemy. Then I want to return from this function a new swimming enemy, and I'm going to pass it the name that was passed to us from the function, right? In this case, it would have been Aquaman. So Aquaman comes in here as name. We're going to construct a new swimming enemy, passing it that name for the constructor. It's going to get instantiated to this.name. And if we call swim on it, then we're actually going to get Aquaman can swim. So let's test this out. I'm going to run this code. Check that out. Isn't that totally crazy? That's pretty awesome, right? Now you can refactor this. In fact, I encourage you to try to change this to the same syntax I showed you earlier with the crazy looking one line return and the new and the bracket syntax. But what we just did is actually two different ways to actually work with returning classes from our enemy factory. This one doesn't actually need an instance of enemy factory. It can actually return it directly, right, from the enemy factory object itself. It has a function to return classes. In this case, we would have to actually create a new enemy factory first, which arguably is a little bit awkward and maybe a little bit more confusing and less like ergonomic for developers. Now, what I want to then do is log out all of these enemy factory.proto. Let me just copy these down here so I don't get too confused. Do this just so that we can actually see. So I want to log out the prototypes or the actual keys in each of these prototypes. So I'm going to say console.log object.get own property names, and I want to pass in each of these things just so that we can actually see what those might be. So I'll just duplicate this a bunch of times, and the first one is going to be enemy factory. Then I want to do factory. Then I want to do factory.proto, which is the prototype of factory, the instance factory. Then I want to do flying.proto. Then I want to do swimming.proto. Okay, I'd like you to think, what are we actually going to see for this, right? This is definitely a tricky one. All right, I'm going to pull up my terminal. I'm going to run this again. And what we can see is that for enemy factory, which is our first one, I might need to just make this a little bit smaller so we can actually see. Our enemy factory, which is our first one, is length, prototype, name, and generate swimming enemy. If you recall, last time when we actually logged this out, right, up here, we saw length, prototype, and name, but we never had generate swimming enemy, but now we do. That's why we can do enemy factory dot generate swimming enemy, because we literally added it to the enemy factory object. Okay, factory itself has nothing on it, right? Because there are no methods on factory itself. There's also no instance properties or fields on factory itself. Now you're probably thinking, wait a minute, where is generate flying enemy? That's on enemy factory. But take a look at this, right? If I scroll back down here, we see that generate flying enemy is not on factory, right? But it's on the factory's prototype, the instance of factory. So I should actually mention here that factory, I was actually incorrect there. Technically, it's an instance of enemy factory, right? So we're getting back a new enemy factory, which is an instance of the enemy factory, but generate flying enemy is on the prototype, if you remember previously, right? In the previous video, we saw that all methods, including the constructor, are on the prototype. They're not on each individual instance. The only thing that's on the instances themselves are the actual fields, okay, which we don't have in this case. But we'll see in a second, we do have for our flying enemy, and we do have for our swimming enemy. So, or actually I keep saying enemy, I guess they are enemy. So if we look at flying.proto and swimming.proto, we can actually see that they have a fly and a swim function on the prototype. And I should probably also just log these out. I'll just log out flying really quick, and then I'll log out swimming really quick as well, just so we can see what that is. I know this is getting very, very long with the amount of logs that we have on the right-hand side. But what you can see is that flying and swimming have their instance of name set up, right? But their prototypes, which are flying enemy and swimming enemy respectively, have their constructor, but also the actual method in them, fly and swim, right? So the name is coming from this dot name right here for swimming enemy, and this dot name right here for flying enemy. That's why we have name inside of the object, but the method fly and the method swim are in the prototype right here, which also has a constructor, just like we saw for generate flying enemy. Now, there is a lot to unpack with what I just showed you, right? This is just a lot of code, which is why I set it up as a bonus. But if you really dig through these, I encourage you to do more logging, try out to create a third one, for example, look at the prototype, look at the prototype, and really try to pull this apart and make sure that you can explain what you actually see in the console results. If you end up doing that enough times, you end up gaining a huge vast of knowledge when it comes to prototypal inheritance, but also how object-oriented programming works in JavaScript, and it will take you a really long way. I hope you enjoyed this set of exercises. It was really fun putting it together for you. If you did enjoy it, I'd love it if you could like the video and subscribe to the channel. Again, as mentioned before, especially in exercise 3, for example, but also the bonus, I'd love to hear in the comments, what did you think of these? Were they fun? What did you come up with for your Space Invaders? How long did this bonus one take you? Did it kind of drive you a bit crazy, or were you able to kind of get through it? And was it helpful? That's really what I want to know. Like, was this helpful to your understanding? Did it really help you figure out what is going where when we're actually using classes together in OOP? So what we're going to do in the next video is we're going to go into another super fun topic. I really can't wait to get to it. I've been holding it off for a while so that we have all this knowledge ready for us. And that is going to be the topic of inheritance and polymorphism, which I hinted at a couple of times already. This is going to allow us to take this idea of object-oriented programming from something very simplistic to what we're seeing right now, which we can easily kind of recreate with the new keyword and functions, to something really, really, really powerful, where we can actually create different versions of a single enemy, different versions of a player, and each of them can work slightly differently, but also slightly the same. And we can test if they're similar to each other or different from each other, all sorts of really, really awesome things, and save us a lot of time, code, and energy. I can't wait to get to that set of videos along with their exercises. I'll see you over there. See you later.